Welcome to the video lecture for Unit 5, Module 11.6. In this one, we're going to discuss nutrition. As always, here are your learning objectives, so be sure to reference these when studying for both your lecture quiz as well as the unit exam. Let's go ahead and get started. The post-absorptive state can be maintained for a considerable period. For homeostasis to be maintained indefinitely, however, the digestive tract must regularly absorb enough fluid, organic substrates, minerals, and vitamins to keep pace with cellular demands. The absorption of nutrients from food is called nutrition. The body's requirement for each nutrient varies from day to day and from person to person. Nutritionists attempt to analyze a diet in terms of its ability to meet the needs of a specific individual. A balanced diet contains all the ingredients needed to maintain homeostasis. Such a diet must include adequate essential amino acids and fatty acids, minerals and vitamins, and substrates for energy generation. In addition, the diet must include enough water to replace water losses in urine, feces, and evaporation. A balanced diet prevents malnutrition, an unhealthy state resulting from inadequate or excessive absorption of one or more nutrients. One way of avoiding malnutrition is to consume a diet based on the Choose My Plate plan. The United States Department of Agriculture created this diagram to offer personalized eating plans and food assessments based on the current dietary guidelines for Americans. The color-coded food group slices indicate the proportions of food that we should consume from each day for the 5 basic food groups: grains in orange, vegetables in green, fruits in red, dairy products in blue, and protein in purple. Oil should be used sparingly in addition to the 5 basic food groups. For more information, you can go to their website. What's more important concerning the food that you eat is that you take in nutrients in sufficient quantities, adequate to meet your energy needs, and quality, including essential amino acids, fatty acids, vitamins, and minerals. There's nothing magical about the 5 food groups. At various times since the 1940s, the U.S. government has advocated 11, 7, 4, even 6 food groups. The key is making intelligent choices about what you eat. Poor choices can lead to malnutrition, even if all 5 food groups are represented. For example, consider the essential amino acids. The liver cannot synthesize any of these amino acids, so you must obtain them from your diet. Some foods in the dairy and protein groups, specifically beef, fish, poultry, eggs, and milk, provide all the essential amino acids in sufficient quantities. They're said to contain complete proteins. Many plants also supply adequate amount of protein, but contain incomplete proteins, which are deficient in one or more of the essential amino acids. People who follow a vegetarian diet, which is largely restricted to the grains, vegetables, and fruit groups, with or without the dairy product group, must become adept at varying their food choices to include combinations of ingredients that meet all of their amino acid requirements. Even with a proper balance of amino acids, people who eat a vegan diet, which avoids all animal products, face a significant problem because vitamin B12 is obtained only from animal products or from fortified cereals or tofu. Some healthy food products, such as spirulina, are marketed as sources of this vitamin. Unfortunately, humans cannot utilize the form of B12 that they typically contain. A variety of important compounds in the body contain nitrogen atoms. These nitrogen compounds include amino acids, which are a part of the framework of all proteins and protein derivatives, such as glycoproteins and lipoproteins, purines and pyrimidines, the nitrogenous bases of RNA and DNA, creatine, important in the energy storage in muscle tissue as creatine phosphate, porphyrins, complex ring-shaped molecules that bind metal ions and are essential to the function of hemoglobin, myoglobin, and the cytochromes. Despite the importance of nitrogen to these compounds, your body neither stores nitrogen or maintains reserves of nitrogen compounds, as it does carbohydrates, as in glycogen, and lipids and triglycerides. Your body can synthesize the carbon change of the end compounds, but you must obtain nitrogen atoms either by recycling nitrogen compounds already in the body or by absorbing nitrogen from your diet. You're in nitrogen balance when the amount of nitrogen you absorb from your diet balances the amount that you lose in urine and feces. This is a normal condition and means that the rates of synthesis and breakdown of nitrogen compounds are equivalent. Growing children, athletes, people recovering from illness or injury, and pregnant or lactating women actively synthesize nitrogen compounds. These individuals must absorb more nitrogen than they excrete. Such individuals are in a state of positive nitrogen balance. When excretion exceeds ingestion, a negative nitrogen balance exists. This is an extremely unsatisfactory situation. The body contains only about a kilogram of nitrogen tied up in the nitrogen compounds, and a release of 1/3 can even be fatal. Even when energy reserves are metabolized, as in during starvation, carbohydrates and lipid reserves are broken down first, and nitrogen compounds are conserved. Like N compounds, minerals and vitamins are essential parts of the diet. Your body cannot synthesize minerals, and your cells can generate only a small quantity of very few vitamins. We'll consider minerals and vitamins next. Minerals are inorganic ions released through the dissociation of electrolytes. Minerals are important for three reasons. One, that ions such as sodium and chloride determine the osmotic concentrations of body fluid. Potassium is important in maintaining the osmotic concentration of the cytosol inside body cells. Two, ions in various combinations play major roles in important physiological processes. As we've seen, these processes include the maintenance of membrane potentials, like the construction and maintenance of the skeleton, muscle contraction, and the generation of action potential, the release of neurotransmitter, hormone production, blood clotting, the transport of respiratory gases, buffer systems, fluid absorption, and waste removal. Three, ions are essential cofactors in a variety of enzymatic reactions. For example, calcium-dependent ATPase in skeletal muscle also requires the presence of magnesium ions. Another ATPase required for the conversion of glucose to pyruvate needs both potassium and magnesium ions. Carbonic anhydrase is important in the carbon dioxide transport, buffer systems, and gastric acid secretion. This enzyme requires the presence of zinc ions. Finally, each component of the electron transport system requires an iron atom. The final cytochrome, A3 of the ETS, must bind a copper ion as well. The major minerals and a summary of their functional roles are listed in tables 25-2 that you see here. Your body contains significant reserves of several important minerals. These reserves help to reduce the effects of variations in the dietary supply. However, the reserves are often small. Chronic dietary reductions can lead to a variety of clinical problems. Alternatively, a dietary excess of mineral ions can be equally dangerous because storage capabilities are limited. Problems involving iron are particularly common. The body of a healthy man contains about 3.5 grams of iron in the ionic form of Fe2. Of that amount, 2.5 grams is bound to the hemoglobin in circulating red blood cells. The rest is stored in the liver and red bone marrow. In women, the total body iron content averages about 2.4 grams, with roughly 1.9 grams incorporated into the red blood cells. Thus, a woman's iron reserves consist of only about 0.5 grams, half that of a typical man. For this reason, if the diet contains inadequate amounts of iron, premenopausal women are more likely to develop signs of iron deficiency than are men. A vitamin is an essential organic nutrient that functions as a coenzyme in vital enzymatic reactions. Vitamins are assigned to either two groups based on their chemical structure and characteristics: fat-soluble vitamins or water-soluble vitamins. Vitamins A, D, E, and K are the fat-soluble vitamins. Fat-soluble vitamins dissolve in lipids. You absorb these vitamins primarily from the digestive tract, along with the lipid contents of micelles. However, when exposed to sunlight, your skin can synthesize small amounts of vitamin D, and intestinal bacteria produce some vitamin K. The modes of action in these vitamins require further study. Vitamin A has long been recognized as a structural component of the visual pigment retinol. It has more general metabolic effects that are not well understood. Vitamin D is ultimately converted to calcitriol. This hormone binds to cytoplasmic receptors within the intestinal epithelium and helps to increase the rate of intestinal absorption of calcium and phosphorus. Vitamin E is thought to stabilize intracellular membranes. Vitamin K is necessary in a reaction that's essential to the synthesis of several proteins, including at least 3 of the clotting factors. Fat-soluble vitamins normally diffuse into the plasma membranes and other lipids in the body, including the lipid inclusions in the liver and adipose tissues. As a result, your body contains a significant reserve of these vitamins. Normal metabolic operations can continue for several months after dietary sources have been cut off. For this reason, a dietary insufficiency of fat-soluble vitamins rarely causes signs and symptoms of hypovitaminosis or vitamin deficiency disease. However, other factors can cause hypovitaminosis involving either fat-soluble or water-soluble vitamins. Problems may be due to an inability to absorb a vitamin from the digestive tract, inadequate storage, or excessive demand. Too much of a vitamin can also have harmful effects. Hypervitaminosis occurs when dietary intake exceeds the body's ability to use, store, or excrete a particular vitamin. This condition usually involves one of the fat-soluble vitamins because the excess is retained and stored in body lipids. Most of the water-soluble vitamins that you see here in Table 25-4 are components of coenzymes. For example, NAD is derived from niacin, FAD from vitamin B2 or riboflavin, and coenzyme A from vitamin B5 or pantothenic acid. Water soluble vitamins are rapidly exchanged between the fluid compartments of the digestive tract and the circulating blood. Excessive amounts are readily excreted in urine. For this reason, hypervitaminosis involving water soluble vitamins is relatively uncommon, except among people who take large doses of vitamin supplements. Only vitamins B12 and C are stored in significant quantities. Insufficient intake of other water soluble vitamins can lead to initial signs and symptoms of vitamin deficiency within a period of days to weeks. The bacteria that live in the intestines helps to prevent deficiency diseases. They produce small amounts of 5 of the 9 water-soluble vitamins, in addition to fat-soluble vitamin K. The intestinal epithelium can easily absorb all of the water-soluble vitamins except B12. The B12 molecule is large. It must be bound to intrinsic factor from the gastric mucosa before absorption can take place. Diet has a profound influence on a person's general health. We've already considered the effects of too many or too few nutrients, above normal or below normal concentrations of minerals, and hypervitaminosis or avitaminosis. More subtle long-term problems can occur when the diet includes the wrong proportions or combinations of nutrients. The average diet in the United States contains too much sodium and too many calories. Lipids, particularly saturated fats, provide a great proportion of these calories. This diet increases the incidence of obesity, heart disease, atherosclerosis, hypertension, and diabetes in the U.S. population.